Hello, everyone. It's good to come your way with another interesting series under the academia series. Today, I'm coming your way with another interesting topic on light energy. And before we start, I would like to tell you or inform you to contact me if you need any help or a further explanation on the details that appear on your screen. Right, so now let's start with today's lesson, light energy. All right, here we are. At the end of today's lesson, learners are expected to demonstrate that light travels in a straight line and also describe the operation of the pinhole camera. Let me start by introducing what light is. In fact, light makes our vision possible. Without light, we will not be able to see anything around us. Images are seen because rays emanate or which are produced from the object gets into our eyes, which is interpreted by our brain to help us see whatever object it is. It is also interesting to know that light determines the behavior patterns of living organisms. Talking about human beings, we are active during the day, but when darkness comes around, we find ourselves being inactive. That's where we sleep a lot. Some other animals, such as bats, they become active during the night and then inactive during the day. So if I say light determines the behavior patterns of organisms, that's what I want to mean. Now, before we continue, there are some terms that you have to understand to make you understand this topic in as a topic as a whole. And the first term that I want you to know is luminous body, then non-luminous body, then the term transparent, then translucent, opaque, and then lastly we have rays and beams. Let's start with the first one. When we say luminous body, they are bodies that can produce light on their own. Example, we have sun, electric bulb, burning of firewood, and then an organism called the firefly. So there we are with some pictures to illustrate that. We have the sun, we have an electric bulb, we have firewood producing light, and then also the glowworm. In contrast to this, we have non-luminous bodies, which are bodies that do not produce light on their own. You may see them because they reflect light from other sources. Water or a glass of water, camera. In fact, most objects are non-luminous. They do not produce light on their own. Then we have what we call transparent, translucent, and opaque bodies. Transparent bodies are bodies that allow most light to pass through. Before I even go ahead with these terms, let me explain that when light falls on objects, three things may occur. One, those light rays may be absorbed, or it may be reflected, or the object may allow the light to pass through. So number one, the light rays may be allowed to pass through the object. It can also be reflected, or it can be absorbed. So please take note of that. Pass through the object, the light ray being reflected or absorbed. So when we come to transparent objects, they allow most of the light to pass through them and then reflect or absorb small quantity of the light. Example, we have clear glass, clear plastic clear plastic material, and clean water. They will allow most of the light to pass through. Then we come to translucent objects. Objects that allow small amount of light to pass through, whilst they absorb most of it or reflect and reflect very little of those lights. Again, they will absorb most of the lights, reflect very little of it, and also allow small amount of light to pass through. Example, we have frosted glass, oiled paper, and colored plastic. I'll show you images to illustrate that very soon. Then finally, we have opaque objects. They do not allow light to pass through them. They will reflect or absorb all the light rays. So looking at this is a clear plastic container. It can be described as being transparent. It will allow most light rays to pass through. This one is a translucent material. It will allow certain amount of light and then reflect or absorb some. And then we have the opaque. This one won't allow light to pass through at all. The same way clear bulb is transparent, a colored bulb is opaque, and this one here will allow some light to pass through. Now let's continue. The last terminology that I want you to understand is rays and then beam. A ray is the path along which light travels. So light is able to travel from one point to another through a path which we term as ray. And then a group of rays form a beam. So when two or more rays are moving together, we shall call that a beam. Now let's come to our main topic for today. What is light? Light is a form of energy that travels in a straight line and makes vision possible. We have two main sources of light. We have the natural sources, such as the sun. Remember, the sun is also a form of star. We have the firefly, we have the glowworm, some deep sea fishes as well can give off light naturally. Then we have artificial sources of light. Example, we have the electric lamp, firewood, lantern, and torch lights. These are termed as artificial sources of light. So here are some images to illustrate what I said. We have sun, then the firefly. They are all natural sources of light. And then we have the glowworm. Here we have a whole lot of, or a group of glowworms, which is illuminating a certain area in the night. So you can see the image here. I think it's very interesting to watch. Let's go on to artificial sources. These are sources of light that are man-made. They are man-made. Example, we have firewood, lantern, torchlight, and other more. So fires or light from firewood, bulb, they are all artificial sources of light. Now, what are the properties of light? Light has certain properties, and these are: one, light travels in a straight line. Light travels with a speed of 3.0 times 10 to the power 8 meter per second in air. Please, in air is very important. You have to add it, because in water, this speed will change, and other medium, this speed will also change. So this speed becomes valid only in air. Light can be reflected. Light can also be refracted. We will look at that in our third series of presentation. Now, we mentioned that light travels in a straight line. This property that light travels in a straight line is called the rectilinear propagation of light. This principle that light rays or light travels in a straight line is termed as the rectilinear propagation of light. And this is a simple experiment that we can all perform to illustrate rectilinear propagation of light. So let's watch a video to illustrate that. I'd like us to watch a video to illustrate that. Yes, here, let us get for ourselves 3 cardboards of the same size and then create holes at the same spot in them as shown in the video. Then light a candle and then arrange the cardboard such that the holes are in a straight line. You can use a thread to help you set up this. First of all, when you shift one of the cardboards, you realize that you will not be able to see the light when you shift one of the cardboard. But then when the cardboard are all straight, you will see the light. This is an illustration that light travels in a straight line. Light travels in a straight line. Once again, if you shift one of them, it blocks the light rays and you will not be able to see it. All right. So there we are with that. Let's continue. Then the last thing that we want to talk about today is the pinhole camera. The pinhole camera. In fact, it uses the operation, or it uses its operation is based on the fact that light travels in a straight line. That's one application of that property, rectilinear propagation of light. A pinhole camera is just a device which are used to capture images of objects. In fact, it has been in existence for some time now, and we still use it, even though with the introduction of digital cameras. Yes, pinhole cameras are still in operation. Now let's look at it. Understand that before an image can be formed, we need two rays to converge, to meet. Two rays from the object will meet, and then it will form the image of that object. So the operation of the pinhole camera is that we assume one image from the top of the object, and then one ray from the top of the object and another ray from the down part meet and form the whole image. The name pinhole is given to this device because the entrance or the hole through which this image must pass, the rays must pass, should be pin-like, very small. Hence the name pinhole camera. Let's watch this video to illustrate that. Let's watch this video to illustrate that. So we can have for ourselves. Okay, here we are. Yes. So we have candle once again here. We assume that this is a screen where we can see the image of the candle. So image from the top of the candle comes here because it will travel in a straight line. The rays from the bottom part will also travel in a straight line and gets to the top over here, making the object turn upside down inside the screen or the device. All right. Let us continue. So for the operation of the pinhole camera, images are inverted. I'll talk about that later on in the device. And from here, images raised from the down part gets to the upper part, and raised from the upper part it comes over here. So it turns the image upside down in the device. Now you can also construct a pinhole camera, a simply made pinhole camera in the house. Let's quickly look at it. We have this. You can create here. You can get a tin of milk, an empty tin of milk, empty tin of milk. Then you cut one side open. Cut one side open. Cover it. I think let me go back a little bit so that you know the construction. Okay. So just cut one side open. Yes, here, and you make a hole, small hole. It should be pinned, and then on the other side too, you cut it open, face a piece of paper there. Then you light a camera candle here, and then you can observe the image at the back here turn upside down. You can observe the image turn upside down over here. All right, so this is a simple construction of a pinhole camera. All right. Now, characteristics of images formed by pinhole cameras are: one, they are real. I'll explain that in details very soon. When I say images are real, it means they can be received on a screen. You can cast them on a screen. Two, they are inverted. We realize that the images formed in a pinhole camera turns upside down, and that's what we mean by inverted. And then they are diminished. That is, they are smaller in size. They are smaller in size. Images such as these, formed by mirror or water, cannot be cast on a screen, so we call it a virtual image. Virtual image. Yes, please, I want to end here for this particular series. Expect another series on light where I'll talk about shadows and information of